Hey everyone, you know how in programming there's almost never just one way to get something done? Well, today we're going to take one of the most common tasks you can think of and look at all the different ways JavaScript lets us solve it. Okay, let's get right into it.
So let's say you're faced with a pretty simple task. You have a list of numbers and all you need to do is add them all up. That's it. Sounds easy enough, right? But the real question isn't just can you do it, it's how are you going to do it?
Because in JavaScript, believe it or not, there are at least 6 really common ways to tackle this exact problem. 6! Each one has its own little quirks, its own style, its own pros and cons. And today, we're going to take a tour of every single one. Now, to keep everything nice and clear, we've got one simple mission. We're using this array of numbers, 1, 2, 3, 4, 5, and 6. And our goal, no matter which method we use, is to add them all together to get our magic number, 21. Think of this as our destination for every path we take.
Okay, before we even touch any code, we need to get our heads around two big ideas: imperative versus declarative. Imperative programming is all about the how. You're the boss, telling the computer every single little step to take. Start here, check this, add that, move to the next. In contrast, declarative is all about the what. You just describe the outcome you want, and you let the language figure out the how. It's really the difference between driving a stick shift versus an automatic.
So let's start with the classics, the ones you probably learned first. These are the imperative hands-on loops. This is where we're really getting under the hood and controlling every part of the process. And first up, of course, is the classic for loop. This thing is the original workhorse of programming. Just look at the 3 parts inside those parentheses. You've got the initializer, let i equals 0, which sets up our counter. Then the condition, I less than old array.length, which tells the loop when to stop. And finally, the incrementer I++, which moves us to the next item after each run. You are in total, absolute control. Next, we have the while loop. This one is a bit simpler in its setup. It just asks one question over and over. Is this condition true? As long as our counter, I, is less than the length of the array, it'll keep on running. But, and this is a big but, you have to remember to increase that counter yourself inside the loop. If you forget that I++ line, you're stuck in an infinite loop forever.
And rounding out our classics is the do-while loop. It's kind of like the while loop's quirky cousin. Its claim to fame, it will always run the code inside at least one time before it even bothers to check the condition. It's the act now, ask for permission later loop, and for some specific cases, it's exactly what you need.
All right, so we've seen the manual, imperative ways. Now let's shift gears and look at the more modern, declarative methods. These are usually way more expressive, easier to read, and let us do the same job with a lot less code.
Meet for each. I mean, isn't this just beautiful? You just tell the array, hey, for each item you have, just run this little function. Look at that code. There's no I, no condition to check, no incrementer. We're not telling it how to loop, we're just telling it what to do. Add the number to the sum. So clean.
Then there's the for of loop. Now, the key difference here is its focus. The classic for loop gives you the index, the I, but for of cuts right to the chase and gives you the actual value of the item directly. This makes the code so much easier to read, it's almost like plain English. For each num of new array. I love it. And now for what many consider the pro move, the dot reduce method. This thing is an absolute powerhouse. Its entire job is to take a whole array of things and, well, reduce it down to a single value. It uses an accumulator, which we call ACC, that holds our running total. Then, for each current value, cur, it does something and updates the accumulator. And just like that, our entire problem is solved in one single elegant line of code. So we've walked 6 different paths to get to the top of the mountain. Now let's pull back and look at the entire map from above. Seeing them all lined up like this is, honestly, pretty cool. You can really see the evolution. You've got the classic multi-line manual control loops at the top, and as you move down, the code gets more expressive and way more concise, ending with those beautiful one-liners. Every single one of them gets us to our answer of 21, but the journey could not be more different.
So, okay, we've got 6 options, that's great. But how on earth do you choose which one to use? And more importantly, why does knowing all of them even matter? That is the real question.
Well, here's how it all breaks down. If you need maximum control, say you need to break out of a loop early, or maybe even go backwards, then the classic for and while loops are your best bet. They give you the keys to the engine. But if your main goal is readability and clean code that's easy to understand, for each and for of are fantastic. And then you've got the specialist.
.reduce. When your goal is to transform an entire array into one single thing, a number, a string, an object, you name it, .reduce was built for that. See, the goal isn't to find the best loop, it's to know your toolbox so you can pick the perfect tool for the job you're facing.
So now you have the map. You've seen all the different trails, from the old, winding paths to the brand new expressways. The next time you sit down to code, you're not just looking for an answer, you're looking for the best path